Hello friends, welcome back my YouTube channel MS Maths. In this particular video, I will discuss a topic of fluid dynamics, that is velocity potential function, and we'll discuss further the velocity vector and velocity vector. So basically in this case that we have already discussed the like stream tube and streamline, path line, and the introduction of the fluid dynamics. We have already done within our previous two lectures. So you can also refer to that lecture like to understand the concept or to understand the basic phenomenon and basic working of the fluid dynamics. In this case, we will discuss potential velocity potential function. If the fluid velocity at a time t is q vector, we will which we will denote by this q vector, the component with the component u, v, and w. This we have already derived within our previous lecture. In Cartesian coordinate, the equation of the streamline. Streamline is nothing but the line which is tangent to the fluid flow. Okay, so the equation of that particular line in the Cartesian coordinate, it is nothing but dx by v, dx by u, dy by v, and dz by w. This streamline cut the surface u dx plus v dy plus w dz is equals to 0 orthogonally. Orthogonally cut means that, but like it will cut in manner in such a manner that like the angle between the intersection will be the 90-degree orthogonally. Suppose that suppose that at the considered time t we can find a scalar function phi x y z t, which is in a space and time, space and time, space as well as time. There are two coordinates, okay, which is uniform through the entire field of flow, such that how is it how this like function will be defined, or how like this will written as, if you have a surface that u dx plus v dy plus w dz, which is equals to basically minus of df, because it cuts orthogonally, then m1 into m2 is equals to minus 1. It means that the slope of both the curves, multiplication of like slope of both the curves will be equal to minus 1. Okay, so in this such a manner we will write it as, so now u dx plus v dy plus w dz is equals to minus, so it is d phi by, sorry, dou phi by dou x, then dx, the concept of total derivative, dou phi by dou y and dy plus dou phi by dou z and dz. Now here u is nothing but minus del phi by, sorry, minus dou phi by dou x, v is equals to minus dou phi by dou y, and w is equals to minus dou phi by dou z. So it is equation number 2, or I say it is equation number 1, like equation of string line. Now next we know that the q vector is nothing but with the component u, v, and w. So basically q vector is equals to minus del phi. Okay, minus del phi. It shows the flow. It shows the flow from higher to lower direction. It shows the flow which this negative sign. Okay, in the, like we can write this negative sign shows the, or we can write in this way. So this is equation number 3. For equation number 3 to hold curl q vector is equals to 0. In the case of velocity, or sorry, verticity and velocity, like two vectors will be there. So there is a property that curl q vector is equals to 0. It means the vector will be irrotational. Like to hold this property, the function phi x y z t should be constant to hold this property. It means it is equipotential line. It should be on the equipotential line. Okay. Now, what is the vorticity vector? Now, we'll discuss for a vorticity vector. So, vorticity vector, it is basically curl q vector is not equals to 0. In this case, the curl q vector is 0. It means it is a irrotational. Now, in this case, it is a rotational. Okay. So, xi is equals to del dot q vector. I say it is some quantity, or xi is equals to del dot q vector. The necessary and sufficient condition, for a necessary and sufficient condition. Oh, sorry, it is not dot product. It is cross product, because due to curl. Okay, it is a cross product. So the necessary and sufficient condition for a potential line, that xi will be 0. It means that del cross q vector is equals to 0. So the vertex line is curve. What is the vertex line? So the vertex line is a curve drawn in a fluid such that the tangent to it at every point is in the direction of vorticity vector. So basically it is the definition of vertex line. So the component of the vertex line is xi vector is equals to xi1, xi2 and xi3. So component of verticity in Cartesian coordinate, these are the component of verticity. Now then, the equation of vertex line is basically dx by xi1 is equals to dy by xi2 is equals to dz by xi3. Okay, so this is the concept of vertex line and verticity. So I hope you got the formulas. That, like, the important point is that formula and the potential velocity function to understand this. So thanks for watching my video. Keep watching MS Maths. Please subscribe the channel, share with your friends and all. Thank you. Bye bye.